Hello everyone, welcome to my channel. So today we are going to do Leetcode weekly challenge. First question: longest even odd subarray with threshold. Let us first read this question, then about the constraint, then examples, and then finally the coding part for the same. So here you are given a zero index integer as num and an integer threshold. So we are required to find the length of the longest subarray of num starting at index L and at index R, where L and R in increasing order, and they are basically greater than 0 and less than nums dot length that satisfy the following condition. Nums of L should be, if we do modulo by 2, then it should be 0. That is, nums of L should be even number. Then for all indices I in the range L up to R minus 1, this rule should be followed. And then for all the indices I in the range L to R, nums of I should be less than equals to threshold. So basically when array is given and when threshold is also given, so all the numbers in that subarray should be less than equal to the threshold which is given, and consecutive numbers should follow this rule. So now next thing is that we are required to return an integer denoting the length of the longest such subarray. And we already know that what a subarray is. Here we don't require to return subarray, but we are required to return the length of the longest subarray possible. So when it is a question of longest such subarray, means length of the longest such subarray, then surely there would be multiple subarrays and out of them we are required to return longest subarray. So in that context, we would be required to have a variable which will store the maximum out of present and the previous length so far. So that would be the case, and that would be the answer which we are required to return. So from the question only we got the hint at how we are required to go ahead with the question. And now about the constraints. So here constraints are pretty much low. So as per these constraints, we can easily go ahead with n square. And surely if n log n is possible or order of n is possible, then that also we can go. But yeah, at max, we can go ahead with n square solution. So let us go ahead and solve with an n square solution. So before that, let us check that um, how in context to constraint we are required, in context to examples, we are required to go ahead with the solution. Means let us first exactly check that how we are required to do this question. So here in this area, what is the first number which is even number? Uh, and also divisible by even number are always divisible by 2. Yeah, so what is that first number which is even number? So here that is 2. So we are required to start our array from 2. And then what next thing which we are required to check is that it should be less than threshold, and also it should be, means the other, excuse me, so the other number which we are required to inculcate in that array, that should follow this rule. Means this 2 modulo 2 should not be equal to 5 modulo 2. And that is for sure they won't be equal because it is 0 and 5 modulo 2 is 1, I guess. No, it is 1. And 5 is also less than equal to 5 and 2 is also less than equal to 5. So our array will now contain 2 and 5. Now comes the next part, that is this 4. So now we need to check that 5 modulo 2 should not be equals to 4 modulo 2, and that is also for sure because here it is 0 and here it is 1. So we can add an also 4 is basically less than our threshold. So that's why our length of subarray here is 3. So this is pretty much straightforward, like this it would be. Here we can see that only 2 is the one which satisfies the starting point, and after that there is no other element, so that's why 2 is the only one, and that's why we are returning 1. Here we are starting from 2 going till 3 because 3 modulo 2 is 1 and 2 modulo 2 is 0, then going with 4. So that's why Here it's 3 as our answer. So these are pretty much simpler one examples which are here. But if somehow there is some example like this, means n is there, 4 is there, and 2 is there. Oh, not 2. Okay. This is the example which is there, and 18 is the threshold. So all these lie bit less than 18 threshold, right? So all these qualify. But if we do 2 modulo 2, that is also equals to 0. And if we do 10 modulo 2, that is also equals to 0. Right. So in this context, we are required to either start from this or start from this. Right. But if we start from this, then we can only able to return 1 as the answer. As after this, this doesn't satisfy the condition of nums of I plus 1 modulo 2 not equals to nums of I modulo 2, right? So that's why we will be starting from this. And here, the sub-array size is basically 2 rather than 1. So in this context, our answer would be 2. That is the length of the longest sub-array. So for these type of test cases only, we are required to maintain a variable where we would be storing the maximum out of both of them. So in this, how we are required to do this question. That is the part. Before starting with coding part, let us go ahead and check that how we are required to code it. Right. So the thing would be that first thing is that we will start iterating from I to n. I is equal to 0 to n. In this, we will be first checking that what is that number where basically means if we do nums of I modulo 2, then it should be equal to 0. And moreover, this n of I should be less than threshold, less than or equals to threshold. These two conditions we are required to check. Then we will be assigning this I to some, let us say, because this is L and it is index. So L index equals to I. And with this, then we will be starting one more for loop. And in this for loop, we will be starting from int I equals to, earlier we used I, so let us take some other. In j equals to L index plus 1, because we have already considered that. And here we will be equating count equals to 1, not count plus plus, but count equals to 1, because there could be a case where we are going ahead with maximum out of 2 sub-arrays, right? So in that context, we always be required to start a count equals to 1 when it is at this particular point. And then we will be going ahead for this less than the size, that is n, and then moving ahead. So in this, now we will be checking that if our nums of I minus 1, that is means modulo 2, is is not equals to the present which is there, and also our this particular which is there means nums of I should be less than equals to threshold. If that is the criteria, then we will be incrementing our count. So that is the thing which we will be doing here. And then after this for loop is done, means this for loop is done, then we will check that answer equals to maximum of count, comma answer. That thing we will be checking. And at the end, that will be returned. So this is how we are required to do this question, and it would be surely n square solution because we are using nested for loops, right? In the worst case scenario, it could be that I start from 0 to n and j start from 1 to n. So that's why it is simply n squared solution. So that's the things are here. Now let us code this solution because I have already given you overview that how we coding. So let us go ahead and code. For int I is equal to 0, I less than n I plus plus. So first thing we will be checking is that if our nums of I, which is there, if we do modulo by 2 is equal to 0, and our nums of I is basically less than equals to threshold. So if both of these conditions hold true, then in this context, Here some more variables we require. One is L index. L index is equal to -1. Then answer equals to -1 and count equals to mm, let us say -1 only because we will be incrementing count here only. So count equals to 1. So that would be the thing. Means when both of these conditions satisfy, then in that context. Now after this, we are required to go ahead with one more for loop. So here we will be starting with L index plus 1. And the thing is, see, if it doesn't satisfy this condition, here unknowns in this product L index equals to I when both of above condition holds true. So that would be the thing. But here one more thing is there that if L index is still -1, right? And here we are going there with L index plus 1. That will become -1 plus 1, 0. So they will be starting from 0, even if L index is not assigned. So in that context, we will keep a so that's why we will be required that if L index is not equals to -1, then only it will go ahead with the same. And here j should be less than n and j plus plus. So that's the usual which we do in for loop. So now in this for loop, what we are going to do next is first we will check that if and none of j which is there, it is less than equals to the threshold. First thing is could be that, and then after that we are required to check that if and none of j is and if we do modulo by 2, then its modulo is not equals to nums of j minus 1. Uh, this would be the criteria, means both of them are not equal. So in that context only we will be incrementing our count. Else if that is not the case, then we are required to break from this loop. Else it will count for the next one also. Means if the test case is something like this, means 2, 2, 10, and then 3, then it will 3 and 4 also say. So then in this context, it will return 3 as the answer, but it shouldn't. Mm, Although here it does fine, means there could be some test case where it shouldn't return something like uh, that, that test case could be here, although it will return 2, but it won't be checking for those which are the right ones. There was one test case also, just forgot. One more. Yeah, we write 4 here, right? So here if you check that here 2 is there, then it will skip for 4 also and it will skip for 10 also. So in all these contexts, it will be just returning 1 as the answer. That is not true here. So that's why we are just breaking out from here. And in this context also, we will break out from here. Now this thing is done here. So now the thing is that if L index equals to -1, and in that context answer would be equal to 0, else we will be directly returning the answer as it is. So this whole thing, but now comes the part that we are required to also check for the fact that which is the maximum one. Answer comma count. So here we will be checking that which out of them is greater, and that would be returned at the end. There is something missing. Answer already. So it should be they starting from this, and it should start from here only. And if it is less than equal threshold, then only it should go ahead with this. Okay, yeah. And this it is not. Hmm. Okay, let us put the box. I mean, two, it's fine. One, zero, two, and three, and one and two and two and three. That is fine. Is still here. It's all fine. So now again it is taking one and two, then from two and three. That is the thing. Just going to it again. Right. Okay. Seriously, this is so strange. No, it is not even working for it. Okay. Basically, earlier I had quoted the same. What has happened to this one? The thing is that here already it is modulo 2, modulo 0. That is completely fine. And it should be less than threshold. Count should be always equal to 1 when it starts from here. An index, it will be updated to I. That is for sure. Then first we need to check that if this index is not equals to -1. And in that context only we can proceed ahead. That also it will start from just the next one from where it was earlier. And in that also, we'll first check that if it is less than threshold and also if it is in this criteria. Now I'll modify the same one which was not working. So here again. Now here we are starting the count with 0 and answer -1. So here this is the first loop in which we are checking that if this number is modulo by 2 equal to 0 and less than this. Then after checking that if this is not equal to -1, then we are going ahead and running the loop from that point and then checking that if threshold it is less than threshold and also this condition is satisfied. then only we'll increment count, else we'll break, so that it doesn't check for just the next one because of this for loop. And again, we are breaking if this condition doesn't satisfy, again same reason, so that it doesn't check for just the next one. And then after this for loop and after this if condition is done, then after that we are checking for what is the maximum count. And then at the end, if I L index is equals to -1, then our answer would be 0, else answer whatever it is that we are checking. So basically earlier we were checking our answer just after this. So because of that, it was checking again and again, and that's why it was just taking the same and giving us the TAD. Now, if we submit this solution, then gets accepted. So this was all for this particular question. If you still have any doubt, you can comment that down. Yeah, it took a lot time for this. That's fine. Yeah, so this was all. Thank you.